Hello everybody, welcome to Chapter 3. So before we get started, let's talk about Cisco. Years ago, and I'm talking like maybe the 70s and 80s, Cisco had like some like the giants of like the IT industry. Crazy, like super genius networking guys and gals. And they came up with different things or different methods to do stuff as the internet whole thing kind of grew. Remember, the internet kind of started out, it was just a couple military bases, and then they started adding a couple colleges, and it kind of grew out of there. So when it first kind of became public, it was just everybody had dial-up, things were slow. Cat 3 was common in businesses that actually had internet or had cabling and had networking stuff. Microsoft wasn't really even a thing. Novell was kind of big back then. We had Token Ring and these crazy old proprietary systems. But these giants or these geniuses at Cisco were able to come up with ways, and they kind of like saw into the future. So like they understood that RIP was not going to be like the routing protocol of the future because it only used hop count, which in the early days when everybody just had modems, that was fine. Our typical internet speed was 56 kilobytes. So RIP was fine for that because everybody was kind of at the same speed. But they saw like ahead and they said, oh, well, eventually we're going to move on, blah, blah. So they came up with routing protocols like the Interior Gateway Routing Protocol that nobody else had. And then for switching, they came up with their own proprietary way to segment your network based on switches, and it was called ISL, Inter-Switch Link. And those are the big technologies that really helped Cisco to become the powerhouse that it was. In those early days, Cisco, they kind of owned the market. Then obviously everybody, copied them. And then we came out with, Juniper and Palo Alto and things like that. And eventually they all started chipping away at Cisco's market share. And now I think they're about 46% depending on where you read. But again, at one time they were almost 100%. The entire internet, everything was all Cisco. And now all their cool protocols they came out with, like Interior Gateway Routing Protocol and ISL, have all been duplicated or kind of copied by the International Standards Organization. And now we have like VLANs, we have 802.1q, we have OSPF, and we have all these open source things that everybody else can use to kind of match Cisco. All right, so let's move on to VLANs. So what happens when you have a 500 port switch and it receives a broadcast? Well, obviously it goes out 499 other ports. When a broadcast comes into a switch, it's forwarded out all other ports except for the ingress port. So all other ports become egress ports. Now, why is that important? Well, Ethernet, which we currently use, and I feel that like within the next 20 to 30 years, it's kind of got to go away and everything's going to be wireless and cellular, blah, blah. But anyway, so Ethernet uses carrier sense multiple access with collision detection. And what that means is it listens for the line to see if there's anything coming. If the line is free and nothing's coming in, it tries to send. When it sends, if something collides with a packet, it sends a jam signal. Both packets go back to their source. Both those devices will then wait a random amount of time. There's like an algorithm that generates that. And then they start the whole process again. So if I'm getting broadcast and it's colliding with, and I can't send because obviously I'm monitoring the line, and if a broadcast is coming in, I won't send. So it adds delay. Now, is this delay noticeable to humans? Probably not. But if you had like benchmarking software, you would see there might be a 10 millisecond, a 2 millisecond like delay as you're trying to communicate. And you might remember in class, like when I opened up Wireshark, and just for 10 seconds, in the one class I had over 850 packets during the day, but in the evening when there were a lot fewer classes going around, I only had like 150 packets in that 10 seconds, but that was all broadcasts. So VLANs allow us to segment our switch into different areas. So we can limit broadcast to different areas. So we can do it by division like IT and HR and sales, or we could do it by geographic location like Massillon and Bolivar, or we could do it by floors of the building if we have a big enough building. So in essence, a VLAN is just a way to break up the network into smaller pieces. And there are no rules about how to do that. It's up to you. At whatever point you see that maybe a geographical location or department or whatever, you're monitoring it and you're seeing too many broadcasts, and you think, okay, now's the time I need to start separating some stuff. That's really when you kind of put it into practice. So there are no rules rules or something about when you add VLANs. All right, the benefits of VLANs, obviously we have smaller broadcast domains. Less broadcast or a smaller broadcast domain in sales and marketing, and they're separate. Now the marketing broadcast will not interfere with the transmission of packets in sales. Improved security, so you can only view people that are in your VLAN or your network. And each VLAN is its own subnet, so it's its own network. So it allows you to kind of secure and keep traffic within those segments. So somebody, say, in marketing cannot open up network neighborhood and then browse PCs over in the sales. All right, they also say like it can improve IT efficiency, and obviously you can, because you can limit the broadcast so we can free up more time we can send. They say reduce costs. Basically, obviously, any switch can support multiple VLANs. I think a switch by default can support up to 4,000 VLANs. I don't know if that would necessarily save you cost, but by limiting your segments into smaller pieces, you can buy smaller or less expensive devices. If I'm going to break sales up into 20 PCs, then I can just buy a 24-port switch instead of buying like a 48-port switch for sales and marketing. All right, if you hear my dog in the background, he's got the cone of shame on, so he's not very happy. But anyway, so VLANs also help performance. They reduce the broadcast domains, which reduces traffic and allows more bandwidth for real traffic. And they're simpler to manage because I can say, hey, this junior guy is going to be in charge of the sales VLAN. This guy's going to be in charge of the marketing VLAN, that kind of stuff. All right, your bread and butter commands. These 4 commands, 9 times out of 10, will give you the information so you can see like what's going on with your lab or where the problem is. So first off, we have show IP route. Show IP route shows you the routing table that the router knows. If there's no path to the destination network that you're trying to get to in the routing table, the router will never be able to get there. All right, then there's show IP interface brief, which anytime you deal with a new router or it's a router you're unfamiliar with, will show you all the interfaces, whether they've been IP'd or not, and whether they're operational or not. And it gets a good way, like if you don't know like how old the router is or whatever, it'll show you whether the interfaces are gigabit or fast Ethernet, and whether they're going to use 3 numbers to identify them or 2. All right, next one is show VLAN brief. And show VLAN brief will show you all the ports on the switch and what VLANs they're in, and the VLANs that are created on the switch, which comes in very handy if you think there could be some kind of VLAN issue. And then the last one, and we really get into this later on in the class, is show IP protocols. And that shows you information about the routing protocol. Remember, when you first plug in a router to your network, it only knows about what's directly connected. It doesn't know about any remote networks anywhere else. So you have to either put manual routes in, which we call static routes, to make data go from one place to another, or you have to turn on a dynamic routing protocol and set that up so that the routers will talk to each other and share information. So remember those 4 commands. Those are your bread and butter commands. All right, types of VLANs. So again, here's show VLAN brief. All the ports on the switch are there, and these are the 5 default VLANs. So by default, when you buy a Cisco switch and you pull it out of the box, it has 5 VLANs that are created. All the ports are in VLAN 1, which is the default VLAN, and then there are 4 other VLANs that are created that are for like old legacy technologies like token ring. So if you're ever wondering whether your ports are all in the same VLAN, that command will show you like where the ports are and what VLAN they're in. It also shows you what VLANs are created on the switch. So again, it's great for troubleshooting. All right, there are other types of VLANs as well. Normally we have our data VLAN, and that's where we just push our regular data traffic. There's the native VLAN. The native VLAN is only used on trunks, and we'll talk about trunks in just a little bit. But anything that's not tagged is considered part of the native VLAN. So if a packet comes in from some other source and it doesn't have the VLAN tag on it, it's marked and it's automatically placed on the native VLAN. So whenever we set up trunks, we have to make sure that they have a native VLAN set up on both ends. Then typically we set up what they call a management VLAN, and we use this to remote access the switch. Remember, if I got a 24-port switch, those are switch ports, and we don't put IP addresses on them. but we can put an IP address on a VLAN and then assign one of the ports to that VLAN so that we can remote into the switch by IP address. Remember, 9 times out of 10 when you're in IT, you don't have physical access to the devices. You remote into them. All right, there are also voice VLANs. So we use our voice VLANs to do voice over IP, and with those we can actually set up quality of service to give that more priority than just our internet browsing. And you can see here, so I have a PC that plugs into a voice over IP phone, and then that voice over IP phone would actually plug into the switch port. And that way those two devices can both work, but I only need to take up one switch port. So keep this diagram kind of in mind when we get into access and trunk ports. All right, then everybody has their own policies. Like some places actually have a policy where they put any unused ports in what they call a black hole VLAN. And that black hole VLAN is just one VLAN that they designate that doesn't hook into anywhere. Like let's say it might be VLAN 50. And for some reason that's not hooked up to anything. It's never plugs into a router or anything like that. So anytime we turn off a port, we actually just assign it to the black hole VLAN. So if somebody gets access to that VLAN, it doesn't take them anywhere. They can't do anything in there. All right, in today's business environment, we have multi-switched environments. So as soon as you got more than 25 people, you typically need more than one switch. And we have trunks and we have access ports. So a switch port, remember, does not get an IP address, but it can be an access port where it can only support one data and one voice VLAN, or it can be a trunk and it can support as many VLANs as you want. So here I've got VLAN 10, 20, and 30, and they're all plugged into the switch. And there's another 10, 20, 30 on somewhere else on some other switch that's over here. So all these VLANs need to be allowed across these links here between S2 and S1 and S1 and S3. So these links between switches need to be trunks, and then VLAN 10, 20, and 30 need to be allowed so that they can communicate with their partners on the other side. All right, I mentioned before Cisco had their first proprietary kind of way to segment these. It was called ISL. I don't believe any current switches support ISL, but you may run into an old switch somewhere in a wiring closet or something like that's been in there for 20, 30 years that's still doing its job, and that may still support that. But in today's world, we all support the internet standard, the IEEE or whatever standard, 802.1q, and that's for trunking. And every manufacturer now supports that, whether it be HP ProCurve or Aruba or 3Com, that kind of stuff. When you create a trunk, by default, they support all VLANs. But you can actually specify which VLANs are allowed. Like so, if, for instance, if there's no VLAN 30 anywhere else, if there's only a VLAN 30 over here, then there's no reason to include that across the trunks. All right, this slide just shows you, hey, here's a network without VLANs, so all the broadcast traffic from every PC goes to every other PC, whether it be unicast, multicast, broadcast, so it's bad. But with VLANs, I only get broadcasts from PCs or devices within my VLAN. So remember, by default, only a router stops broadcasts. So by adding VLANs, it's a way we can kind of block broadcasts within a switch. All right, PCs and routers don't really care about VLAN information. They don't really look at that tag. And the tag, it's just a 2-byte field that kind of tells you, it just says, hey, here's the VLAN. So a lot of places don't call it VLANs, they call it tagging. Like I know HP will refer to that as tagging, that kind of stuff. So if you ever hear tagging, it just means VLAN in another manufacturer's devices. And again, the whole field is just four total bytes for the tag. But only switches look at that tag. Nothing else really looks at that tag. All right, whenever I'm creating a trunk, remember, I have to, you don't have to, but by default it allows all VLANs, but you can specify which VLANs are allowed on that trunk. And you have to really do that from both sides. You also have to declare a native VLAN, because what happens if a packet comes into that switch and it doesn't have a tag? It needs to be assigned to a VLAN, so it gets assigned to the native VLAN. And remember, PCs and routers don't care. PCs and routers don't put these tags on there. They just kind of ignore that tag. Only the switches are concerned with the tag. All right, and then here in 2017, Cisco had about 60% of the whole router switch market. Nowadays, and this is just what 7 7 years down the road, they're already down to like 43%. So they're losing market share. Again, it's because they've become like a big bloated whale. Like they have so many different divisions. The company that writes the books is not the same company that writes the test, and not the same company that writes the like the Cisco Academy stuff. So they're all like 3 separate divisions that don't really talk to each other. So that's kind of like some of the reason like they've kind of been going downhill. But anyway, so you can see here HP calls it tagging. You can also see as far as cost goes, Cisco is $250,000 for a 96 port 10 gigabit switch, where HP and Juniper are about $100,000 less. And other things that are kind of biting Cisco in the butt is their price, and not just their normal, like obviously their out the door price is expensive, but the cost to maintain their devices. Like if you buy a 24 port Cisco 2960 switch, you're still going to pay like $125 a year for their SmartNet contract, so you can update your iOS, whenever you need to. Where if I buy an HP ProCurve switch, the cost of the switch when I purchase it covers the like updated iOS for life. So I don't have to keep spending that $125 a month per switch. And I got a buddy that works at the North Canton Spectrum Network Operating Center, like one of their regional hubs. And he said, currently they're about 50-50 Cisco and Juniper. And anytime they buy something new, they're kind of moving to Juniper. And it's just the other softwares or the other manufacturers make their stuff a lot easier. When you guys get to the firewall class, there are videos in there that show you how to do the Cisco ASA firewall and the commands. And then there's the Sonic wall. And Sonic wall, everything's a GUI. You just click the drop down, hit the button, you're all set. But with Cisco, you have to put in all this manual stuff, and it's just a pain. All right, enough cracking on Cisco. Let's move on. All right, switch ports that connect to end user devices are what they call access ports. So we set those up to be access ports. And the command is just switch port mode access. And then that makes it an access port, so it will only support one data VLAN and one voice VLAN. So whenever you have a voice over IP phone, it's actually a 3-port switch inside the phone. So the PC plugs into the phone, and then the phone has a cord that goes out to the switch port, and then on that you can then set call quality of service stuff so that you can give that voice traffic more preference or more bandwidth. So just remember, an access port only supports one data VLAN and one voice VLAN together. It does not support more than one of each, where a trunk can support all VLANs, or however many you want. All right, different places have different policies. Like the one company I was at, they actually had a policy, like there was an actual checklist that whenever you pulled a new switch out of the box, when a new switch would come in, there was a checklist that said this is what had to be done, and they would give you certain commands that you had to run. So we would do interface range, FA01 through FA024 or 48, however many ports the switch had. And then we would do, speed 100 to force the speed to be 100. We would do duplex, full duplex to make sure that it was always do a full duplex. It would never result to half duplex. We would do switch port mode access to make sure all ports were access ports by default. And that would turn off that dynamic trunking protocol that we're going to talk about later. But again, different places have different policies. So depending on wherever you start working, you'll see different stuff. All right, configuration, really easy. By default, the Cisco Catalyst series will support over 4,000 VLANs. The first 1,000 are your normal VLANs, and that's usually the ones that we typically see. We don't really see a whole lot of extended range VLANs unless you're working for a service provider like Time Warner Cable or Spectrum. So the normal range of VLANs, 1 through 1005, and you can see like the 102, 3, 4, and 5, those are for the old legacy stuff. The VLAN information is stored in a file called vlan.dat, and it's on the flash card. And they still use these old compact flash cards from the old camera days, that kind of thing. And that's where it's stored. So that even if you wipe the configuration, so you delete the running or you delete the starting configuration, your VLANs are still there. And that's important because if you buy a switch from somewhere else, like let's say I buy a switch off of eBay or something like that, if I don't check that flash card, there may be a VLAN.dat file in there, and VLAN or switch port 1 and switch port 2 may be in different VLANs. So then all of a sudden I can't communicate between the two devices that are plugged into the switch, and I have no idea what's going on. All right, if you need more than 1,000 VLANs, you can go into the extended range. Those VLANs do not support like a VLAN trunking protocol. which allows me to create VLANs on one switch and have them propagate through the other switches. And I think that's a CCNP topic now. They've moved quite a few things out of the CCNA port. But anyway, I digress. All right. But the extended range VLANs are stored in the running config. Now, you can always theoretically save those, with a copy run start. But if you power cycle the switch and they're all stored in the running config, you would lose them, where anything on the flash card is not lost. Make sure you know the range of the normal range and the extended range, and you know where they're stored. VLAN.dat in the flash, stored in the running configuration. All right, to create a VLAN, you just type in, you got a global mode, and type in VLAN 12, and that's it. And then we technically give them names. It's not required, but we do give them names. And that way it helps us. Like if I tell you, what do you know about VLAN 12? You're like, well, I know it's 12. I know it's one more than 11. But if I tell you, what do you know about VLAN student? Well, that's probably the VLAN where the students are stored. And that's it. Then and go back to whatever mode you want, and you're all set. All right. So again, here's another example. So global mode, VLAN 20, name student, end. And I'm all set. All right, they mention here, if you do not give it a name and you just give it a number, Cisco's iOS by default gives it a name based on the number you put in. So it's a 4-digit number. So VLAN 20 becomes VLAN 0020. That's the name. We'll have to try that out in a lab. All right, moving on. So remember, you can be a trunk port or you can be an access port. Anything that goes to an end user device, a PC, a printer, a voice over IP phone, is a access port. So global mode, and then we go to the interface FA01, enter, and then now we're in sub-interface mode because we're configuration interface. And then we just do switch port mode access. So switch port mode access. And now that it's an access port, it will only support one data and one voice VLAN. And then, once it's an access port, we have to assign it what VLAN is going to access. We do switch port access VLAN 20 or switch port access VLAN student. And then we're all set. So really simple to create VLANs and turn them on. It's just more of a pain about documenting them so that you understand where things are set and how many VLANs you have and where they go to. There's quite a bit of turnover in the management area of IT because people understand that internal people are not valued the same as external people. Meaning, if let's say I am a junior manager and I know the job of the manager and the manager quits and I get offered the job, they'll give me a small raise. They're like, well, you're already making, $80,000. We'll bump you to 85. Where if somebody else comes into the company from outside and they apply for that position, they'll give them, $100,000 or $90,000. They usually offer more to people from outside the company. So because of this, a lot of people have kind of keyed in and seen this, and they know that if they change jobs every 2 or 3 years, they will eventually get to the pay scale that they want in life. So keep that in mind, and remember, a rolling stone gathers no moss. All right, moving on, port assignment. So here's the actual commands. I go to global mode, interface FA018, switch port mode access, makes it an access port, switch port access VLAN 20. I've now assigned VLAN 20 to that port, and I'm all set. And now that port's all set. Again, just keep in mind an access port is only allowed one data port and one voice port. There's some weird tricky questions sometimes on the CCNA. They'll ask you, like an access port can only support how many VLANs? And sometimes it's one. But when they say that, they're saying it's going to be a data VLAN. And that's what kind of makes the CCNA questions so hard, the way they ask some of these questions. But it can support one data and one voice VLAN. All right, so here's an example of me running through the configuration on a port. So first I create the VLAN. I go to global mode, VLAN 20, enter, name student. And then I create another VLAN, VLAN 150, name voice, and I exit. Then I go to the port, switch port FA018, and I say switch port mode access to make it an access port. Switch port access VLAN 20 assigns the data port. Then I do a quality of service command. Don't worry about this. That's all been moved to the CCNP now. You don't worry about that for CCNA. And then we do switch port voice VLAN 150. And it's that word voice that says, hey, this is a second VLAN that I can apply to that because it's going to be different from the first VLAN. So there's switch port access VLAN 20 and switch port voice VLAN 50 for the voice VLAN, and then that's it. When you guys get to CCNA 3, we talk a little bit about quality of service, but it's just like an overview. There are no specific commands that we give. So don't worry about quality of service. That's all been moved to the CCNP. All right, there's always a ton of show commands to give you information. Show VLAN summary just shows you the number of existing VLANs. Well, so there's 12 VLANs on the switch. That doesn't really tell me anything. It doesn't tell me where they're assigned or what their names are, again, what ports are assigned. It just tells me there are 7 VLANs. Well, that's helpful. That's like asking somebody, how much money you got in your wallet, and they say, I've got 5, paper currencies. Well, it has no idea. It doesn't tell me anything. All right, so I digress. All right, if we want to remove a VLAN or we want to take a port and move it off of an access port, we can do no switch port access VLAN. I want to pull the VLAN off of the switch. So that it's switch port access VLAN 20 to put it on, and then no switch port access VLAN to remove it. And that will remove a VLAN from a port. So in our labs, if you accidentally slap a VLAN on a port that you don't want, you can just do no switch port access VLAN. And then after that, do a show VLAN brief, that bread and butter command, and that will show you, make sure that you got that port out of that VLAN. All right, if you want to delete all VLANs, first you can delete an individual VLAN. I can do no VLAN 20 from global mode, and that removes VLAN 20. If I want to remove all VLANs, I have to delete the VLAN.dat file on the flash card. So I have to do delete flash, VLAN.dat. Or I can just do delete flash, enter, then it'll ask me name the file you want to delete, and then I can just type in VLAN.dat, and that will do it. And that kills all VLANs. So in our labs, if you think that there's an issue, always do a show VLAN brief to make sure the ports 1 and 2, whatever you're plugging into, are in the same VLAN. And if they're not, just do a delete flash, VLAN.dat, and that will delete all the VLANs on the switch, and you're okay. In our labs, you will never hurt the switch by deleting the VLAN.dat file. All right, moving on to trunks. So remember, a trunk by default allows all VLANs. So theoretically, when you set them up, you want to say which VLANs are allowed, and you have to specify the native VLAN on both sides. Both sides have to be configured correctly, or you'll see like a native VLAN mismatch or stuff like that. So I go to global mode, interface FA018, whatever port I'm doing it. Switch port mode trunk. So instead of switch port mode access, we do switch port mode trunk, which is now automatically, as soon as you type that command in, all VLANs are allowed on that port. Then we do switch port trunk native VLAN 20, or whatever the native VLAN is. Switch port trunk allowed VLAN, and then VLAN 10-20-30, that kind of stuff. And that's it. So it looks like this. Interface FA01, switch port mode trunk. Remember, anytime you have from switch to switch or switch to router, that has to be a trunk to allow all the different VLANs that you want access to. Anything going to an end user device like a PC or a printer or that kind of stuff, or a server, is its own network. So that would be access port. So switch port mode trunk, switch port trunk native VLAN 99, switch port trunk allowed VLAN 10, 20, 30, 99, blah, 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 and you're all set. Now, in documentation and training, it's always port 99. So they always tell you that the management port's VLAN 99. They always show you that the native VLAN's 99. In the real world, you never want to do that because that's the first thing that the hackers are going to try to do. They're going to send untagged packets and see if they can get access to those different VLANs and do stuff. So never use the same numbers that are used in documentation. All right, if for some reason those 4 bread and butter commands have not shown you, or you've run all 4 of those, and you can't find any information that has helped you, like why your lab's not working, you can do show interface and look at the specific interface. So I can do show interface FA01 switch port, and then I get so much more information. So if I just do interface, like I switch port mode trunk, and then I put a command in there to take the trunk off or whatever. But if I do show interfaces, I can see the switch port's enabled. It's in the trunk mode. It's supporting .1Q, which they all support now. What VLAN is the native VLAN, that kind of stuff. So I get a little bit more information. Now I'm digging further because the other stuff didn't show me enough. All right, then if I wanted to reset the trunk to default, I do no switch port trunk allowed VLAN. No switch port trunk allowed native VLAN, no switch port trunk native VLAN, and I can reset it back to its default state where it allows everything. But it's never a good idea. All right, so again, we have switch port mode access to be an access port, which goes to an end user device, or switch port mode trunk, which goes to a internet device, which is a router or a switch. All right, now the big thing is the dynamic trunking protocol. Dynamic trunking protocol is turned on by default, and this is a Cisco proprietary thing. So all the ports are automatically, like when they're out of the box, they're not forced to be access ports. They're not forced to be trunks. They're access ports that are in what they call dynamic auto, which means they're listening for somebody to ask it to become a trunk. So you can turn that off with the no negotiate command. So I can go to the interface and do switch port no negotiate. And no negotiate is all one word. And that will turn dynamic trunking protocol off on that port. If you want to turn it off manually off all ports, you just do interface range FA01 space dash space and then the last port FA024, and you just switch port mode access, and that forces them all to be access ports. They will not be trunk ports. Because if they're in dynamic auto, they're listening to become trunks. So if a bad guy gains access to an office, plugs his laptop into the port, and says, hey, I want you to become a trunk, now that port becomes a trunk, and it allows all VLANs by default. So now he has access to all VLANs, so that's bad. Okay, DTP has a couple different modes. There's access port, when again, I'm forcing it to be an access port. Switch port mode access does this, and then it will only be an access port and it cannot become a trunk. Or I can do switch port mode trunk, which I'm forcing it to become a trunk, so it will always be a trunk. The default state, when you pull it out of the box, is dynamic auto, and that means all ports are at access ports, but they listen, and if somebody asks them to become a trunk, they will become a trunk. You can also change that to dynamic desirable, which says, hey, I want you to become a trunk. So one of them listens to become a trunk, the other one asks you to become a trunk. So if one port's in dynamic auto and one port's in dynamic desirable, they will form a trunk because the dynamic desirable is going to ask you to become a trunk, and you're going to say, oh, okay, I'd love to become a trunk. Now, you'll need to know this because on the CCNA, they will ask you, and they'll show you like information from both ports, and you'll see like what mode they're in. If they're both in dynamic auto, they will become access ports. But if one's in dynamic auto and the other's in anything else, it typically becomes a trunk. So unless we specifically tell it to become an access port, or they're both in dynamic auto, they will become trunks. So if I specifically make one side an access port, or both ports are in their default state dynamic auto, they will be access ports. Everything else becomes a trunk. Make sure you're aware of that. All right, to verify the mode, show DTP interface FA01. We'll show you the mode that it's in. Again, most places have a policy where they force you to run switch port mode access on all the ports to force them to be access ports so they cannot become trunks. All right, and that wraps up Chapter 3. If you guys have any questions, make sure you let me know. Other than that, have a fabulous week.